Perfect. Thank you. Especially since there's only four of us, five of us now. There's people missing. Um, so again, for that op 10, we'll build that out real quick. That's going to be an easy one. We'll make our stock block too, which we'll talk about later on. So op 20 is the one where we're going to actually build a plate. So I called it out specifically. We're going to use a 4-inch by 6-inch by 1-inch plate. Okay, just a piece of scrap stock you had somewhere in the back. We're going to basically put a couple pins in that and then use a 3/8/16 screw to hold the part down in the seat. Okay. We need to use 2 pins because we want to lock the part in position so it can't move, right? If you only do 1 pin and 1 threaded hole, it can wobble, right? So generally speaking, you're going to have more than one kind of pin. And then you also need to look at the tolerancing. So for this part, there really isn't a whole lot to look at as far as tolerancing goes. Where do I close it? And that's why we can kind of get away with being a little bit loosey-goosey on this. I called out a 5/8 pin for this, which is a good, this is a reamed hole anyways, right? So that's going to be a pretty precise hole. And then we do have some clearance down here in the 397 holes. But again, I'm not going to go crazy. We'll make a pin that's like 397, 396. And we'll say that a little bit of slop is okay. You know, we're not going to go crazy. So we're going to actually draw that, and then we can actually insert that 3/8/16 bolt and bring that into Mastercam too. You know, the bolt isn't the most efficient thing. Maybe there'd be some kind of like finger clamp or something that we'd use instead of that, but we don't have anything drawn in the bolt. It's just an easier thing to do. We'll get more advanced kind of as we go through. So again, the stock setup itself is 3 3/4 by 4 by 0.46. So we are going to machine the entire outside of the part along that entire profile, and then we're just not going to do any facing. We're going to say that the face is already qualified. So it's either been ground or pre-machined, or it's coming in as cold rolled. You don't get to touch that surface. However you want to explain it, that's how we'll go. So there'll be 2 planes, a G54 and a G55. We kind of covered what those are going to be. We're going to use stock for the for both operations. Well, I think I said we were going to use solid stock in this one. Yeah, the next one we're just going to do we'll do a wireframe, but we'll talk about that later. You'll notice the machining itself isn't that bad, right? So op 10 is real simple. I give you all of the information you need for that. I call out the drill chart. So if you don't have that reamed hole chart downloaded, make sure to reference that when you're picking your drill size for your reamed hole. That's something I'm going to let you do some research on. And then I also did not give you the tap drill size for that 3/8/16 on the other plate. So, and again, you just reference tap drill chart over here to get that drill size. It's no big deal. And then at the bottom, I just kind of explain why I'm doing this. So work holding is an important part of manufacturing. A lot of the time during the day courses, they're spending more time on the machines, so we don't really talk about fixturing or work holding or how to make money doing this. And it's important. So this is where we kind of get to play around at night, where we're not on the machine as much, but we can do a lot more theoretical stuff without ripping and blowing anything up. That's why So that's basically the project in a nutshell. Like I said, we're going to start by drawing the fixture plate first. That's the most complicated thing. As far as the second part of the project, which is just the plate, I'm not going to go over the Word document. I will just show you what we are going to be doing on that. You'll probably do this one at home later. It's seriously just a plate with 4 holes in it, I believe. This guy right here. And I give you the stock basically to size. So all you need to do is drill those holes. Same thing. You got to research the drill and tap, and then research the reamed hole because you got some tolerances on here too. A 1/2 inch -1. That'll be a ream. So yeah, you can do that at home at your own pace without me having to get involved, I think. Does does anybody have any questions or want to go over anything with the Word document? Did anybody read this ahead of time? Did anybody see it? Okay, so you may want to download it and read it ahead of time before you start the actual machining stuff. I'm going to keep it up here and we're going to work off of it as a group to build that plate. Okay. So I'm going to start by grabbing my fixture files that I know we're going to need. So I need that Kurt Weiss assembly with nothing in it. And then I'm just going to grab like the 5/8 parallels that I happen to have. If you got 5/8 or a 1/2 inch built, something like that, you know, this would be fine. Or actually 1 1/2, sorry, 1 1/2. If you don't have anything, Steve, you can make them real quick. You got that? Okay. Okay. I didn't get in here early, so I didn't get my stuff. So let me get this real quick. And actually, I'm not even sure I have all these files on here. So let me just download this with you guys. How's everybody been doing on like the file structure and things like that? Has anybody gotten screwed up at all or kind of getting the hang of it? Yeah, okay. Managing all the files can be difficult sometimes, especially if you're not used to working in Windows all day. For me, it's easy. I always forget how much of a pain in the butt it is to learn some of this. There's that. Don't need the blueprint for now. I'll keep that open. So once you get the Kurt Weiss brought into your working directory, go ahead and open the SolidWorks assembly and make sure all the links work. And what I mean by that is when you open up the Kurt Weiss, make sure that you don't have any parts in it or there isn't any existing stuff in there when you open it. It should be blank. And you should be able to move the movable jaw without any issues. I already know that I have mine screwed up. And I haven't fixed it since last week, so I'm going to leave my stuff out of here. Pretend you didn't see it. Because I made the mistake that I tell everybody not to do, which is save the template with all this crap in it by accident. We're not going to use it right away. I just like to have it open and ready for when we're going to start. And then when I see everybody's got their SolidWorks open, we'll go ahead and start. If you do have a handle on what we're doing, feel free to go ahead and start working. Yeah, we're gonna do a picture plate first. We're gonna do a new file and actually draw. Perfect. Okay. So as I mentioned, we're gonna draw the fixture plate first. So the assembly's open for our stuff for our purposes later. I'm going to start by going to do a file and then new. And we want a new ANSI inch template. If you're at home, you probably don't have that, but you can just use a default inch template. No big deal. Open that up. And like I said, I have the Word document open here, so I'll just go ahead and walk you through it, and I will make sure to go slow so that everybody can kind of follow along. We're not going to actually draw the individual pins or anything and then insert them. We're just going to extrude them up from the top of the plate to pretend they're there. Okay. I don't want to make it more complicated than it actually has to be. So we're inside of SolidWorks. I'm going to go to Sketch. We're going to sketch our top plane in this new file. And we're going to start by making the rectangular plate itself first. So in the notes, I mentioned that it's 4 by 6 by 1. So I'm just going to click on the rectangle command, corner rectangle. I'm going to anchor to the center point where our WCS is in SolidWorks. I'm just going to draw that rectangle out to the right, and then we'll dimension it. So 4 by 6, doesn't matter which way you go. I normally do the 4-inch in the horizontal, or the smaller dimension in the horizontal, and then the length. I'm sorry, other way around. 4-inch in the vertical and 6-inch in the horizontal. We're going to be doing that. We're doing the leg first. Yeah, the plate is the first. The plate we'll do at home. Yeah, there's two projects this week, but the plate is stupid simple, so we're not really going to cover that much today in this class. Leg is the one that you want to get banged out real quick here. So there's our fixture plate. We're going to exit this sketch, and we'll go ahead and extrude this by going to the Features tab, doing extruded boss, and then as I mentioned, we're just having a 1-inch thick piece of material here. I'm not having you do any machining of the fixture this time around. We're just going to basically produce it and not worry about it. So after we have that feature, I'm going to save it. And I'm going to put that in the week 5 working directory with everything else for the leg. And we'll call this op10 fixture. Just remember to make sure you have that op10 in there. I always want to see what the file is associated with. I understand it's in the op10 folder too, but it's nice to have the file name there. So we'll save that. And now let's just talk about the hole positioning a little bit. If we do want to center this in the plate, we're going to need to do a little bit of math on that. We'll extrude up the 5/8 pin first, and that's going to dictate where our other two features are. So let me just read through this again for those of you who haven't seen it. So we'll start by making a rectangular plate. We'll create one drilled and tapped 3/8/16 hole that will correspond to one of the 397 clearance holes in the parts. The other two features will be the two pins. One is 5/8 and one at 0.397 respectively. And that is so the part basically can't move around in the X and the Y. And then the 3/8/16 bolt takes care of the Z. Okay. What I'm going to do is we're going to do the 5/8 pin first. I'm going to do a sketch, a new sketch on top of the plate. And then if you hit the space bar, you get a orientation box that you can use to look at the top view. So we're looking straight down on it. I use that shortcut for everything. So if you're not familiar with it, space bar, and then that'll give you the view sheet, and then you can just kind of click on whatever view you want. So I'm going to draw the pin on the left-hand side of the bolt, or on the left-hand side of the block, and then we'll do the other two holes on the right-hand side. So if you're familiar with SolidWorks, all we need to do is drop a circle down, and then we'll dimension it and move it around. So I'm going to drop a circle. If you want to do a shortcut, you can kind of highlight. You can kind of see when you click on circle, you can find the center point of this line on the left-hand side. If you then scroll over to the right with your mouse, it'll latch onto that horizontal. So it's kind of a cheat, you know, so instead of dimensioning it, you can just drop it in and it'll know it's constrained to the center. Then I'm going to place the hole down and just left click and then click OK. So at this point, we'll dimension it. Let's start with the size first. So as mentioned, we're going to have a 5/8 pin there. So I'm going to go ahead and dimension that with Smart Dimension, and that'll be 0.625. I'm just going to double check and make sure that it's in the middle of my part. So this should be 2 inches if you do it. Okay, so in my case, I had that snap point correct, so it's 2 inches. You might as well dimension it. I don't think it'll over dimension if you do. Nope, that's good. So 2 inches from the bottom. And now this is where I want to make sure I get this position right. So if we look at the print, it's approximately going to be like a 1/2 inch down from the top of the part here. I should have done the math on this before. Oh, well, so what I'll do is I'll do 3.5 from the bottom and then add a little bit extra. So if this is 4, if we do 3.75 from the other end of the block. That should send. So inside of SolidWorks, I'm going to do a smart dimension from the center of the circle to the opposite side of the block, so the far side of the block. And then we'll make that, oh, that can't be right. What did I say? Oh, this is the 6-inch. That's right. Hang on one second. So that's 6-inch. So this is 3.5, 375. Dun, 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 dun. 1 second. 0.75, 2 1/4, 1 125. So let's do 4.625 for a dimension in here. 4.625. So we'll be able to confirm this later on. So 4.625 from the bottom of the plate. And basically what I'm trying to do is center the part in this whole assembly. The good thing about SolidWorks versus Mastercam is if we put this in the assembly and we don't like the way it looks, we can come back and modify it. Okay. So I'm not too concerned about it. So that's a good spot. Now, as I mentioned, if you look at the dimension, the spots, dimensions between the holes on the blueprint are actually from that 375 hole. You see it gives us a 1-inch reference dimension there, and then a 3.313 from the bottom there. So what I'm going to do is I'm going to dimension the 2 holes based off of the center point of the circle, the main circle up there. So we need 2 more. I'm going to exit the smart dimension just to get the 4.625 to lock in. And then I'm going to draw 2 more circles on the far side. Actually, one of those is going to be a drilled and tapped hole. So we should probably use the hole command for that. So actually, let's just do the 1 for now. We'll draw the 1 pin. So I'm going to draw 1 circle on the plate. Again, I'm going to try and make sure I snap to the center point of the circle. Actually, it doesn't matter. I'm sorry, it's not in line. So we can just drop that anywhere we want. You know what I was thinking there. The pin that I'm going to do is going to be in the upper right-hand corner. So I'm going to go to the top of the axis. If you can kind of see what I'm doing here. So now I'm going to do a smart dimension again. And on the blueprint, move that over there. So we want 1 inch from center. So I'm going to do a smart dimension from the center of this 5/8 hole to the center of the new one we drew. And drag it over until I get the horizontal dimension that I want. And we're going to make that 1 inch. The actual dimension of the hole of the pin we're going to use for this spot is 0.397. And then I need to figure out what the dimension is from the hole to that. So it's 3.5 minus 0.313. I can do that in my head, but I'm not going to make the mistake of not double checking. If I can find my freaking calculator in here. Bear with me 1 second. Sorry about that. So yeah, so if you're looking at the blueprint, we have 3.5 to the bottom, which means we subtract the 0.313. So we get 3 3/16, 3.187. And that, again, is from the center of the hole. So the 5/8 hole to that should be 3.187. You can do 3.1875 there. That's the official number without rounding errors. Perfect. And you notice that all of our holes are now black, which means they're fully constrained, right? So that's a perfect sketch If you have anything that's still blue, that means you're missing a dimension and there still has to be something that needs to be defined. Otherwise, you're all set. So again, we could do the other hole the same way, but we're actually going to do a threaded hole to make it look like a real feature in this case. So we'll do that next. So if you have a fully defined sketch and you don't have any questions about dimensions or anything, we'll go ahead and exit the sketch. And I'm just going to extrude these a ½ inch basically. So a little bit more than the depth of the part, right? The thickness of the part. So we'll do a ½ inch. You do want to make sure that you're extruding up, right? And again, we're just going to pretend that these are like dowel pins that are sunk into the hole, okay? And just because I hate sharp edges, I'm going to head and put a chamfer around too. So I'm going to go up to where the fillet command is, which exists over where it says SolidWorks cam. And inside of that drop down, you can change it from fillet to chamfer. I kind of hate how they bury that command in there. And I'm just going to add like an 03 by 45 chamfer on the top edges of both of those pins. I think that'll probably look pretty good. 0.03, just something small. After you type in 0.03, after you select those two edges, I'll click OK. And then you should have something that looks like that. Great. So again, after every feature, I try to always make a save. So I'll save the file if something stupid happens. And now the difference for this one is we're going to use the hole wizard versus just drawing in a circle. Okay. I'm going to use the space bar to get my top view again. And then the hole wizard exists inside of the features tab in SolidWorks, about halfway to the right next to extruded cut. I'm going to click on hole wizard. We're going to define the hole first, and then we'll define the location second. So we're looking for a tapped hole for hole type, which is in the second row, straight tap. Standard is anti-inch. Type is going to be tapped hole. We don't need a bottom tap. We're going to go straight through all the way. Our size is going to be 3/8/16. And you can select that from the drop down real easy. Our end condition is going to be through all. We're going to go all the way through the plate. And that should be the end of that. So once you have the 3/8/16 selected and through all is on that drop down, I'm going to scan back up to the top and click over to the positions tab. From the positions tab, I'm going to click on the top face of the part, and it's automatically going to sketch for me. And then it changes to like a pencil icon, and then we can drop that hole anywhere we want and then dimension it. So I'm going to put it roughly where we want it, and then we'll dimension it like we did before. Make sure you don't click too many times because you'll keep dropping holes down if you're not careful. So we got one hole. I'm going to go up to the smart dimension in the upper left. And we're going to do these same dimensions. So you can still grab the center of that big dowel. That should be no problem. So I left click on that and then click on the center point. And then this distance was it 3.1875? 1875. That looks correct. And then it was 1 inch down from the center of the axis of that 5/8 pin. So that should be 1 inch. Perfect. So it should look equidistant from the opposite pin on the other side. And we'll find out real quick when we go to assemble this whether I screwed these dimensions up or not. So again, we had those two dimensions down. I'm going to exit the smart dimension, and then I am going to click the green checkbox for close dialog on the left-hand side if you have something open. And then I'm going to click the green checkbox on the hole position as well. And we should have that tapped hole there. Okay. We could have cheated. We could have just dropped a 3/8 hole in there and called it a day. But if you ever did want to make a blueprint for this thing or something, the whole wizard, make sure you get the right call out in the print when you want to do it later. Perfect. So that is going to be our work holding solutions for the leg. I'm going to save it again. And then what we will do next is we will go in to make the stock block. Okay. The stock block we are going to cheat a little bit because we don't really need it for anything for this lab. But I like to have it so we can fit. So our stock block, we'll save this. Sorry, I'm gonna change the color too on it to something different while I'm in here for the hell of it. So again, to change the color of this, you can select the Op10 fixture on the left-hand side by the tree. And make sure nobody's been trying to get in. Okay, good. So I'm gonna right-click and go up to Appearances. When you left-click on the caret to drop down, it shows you the Op10 solid. And then I'm just gonna make this like a blue or something, just so it stands out, or yellow compared to the rest of the stuff that we're working on. You can pick anything you want that's not red. And we'll leave this open because it'll make it easier for us to assemble later. Any questions so far? Doing okay? All right. So now, per our Word document here, we're going to make an aluminum stock block. That's going to be 3 3/4 by 4 by 0.46. So that's real easy. I'm going to go up to File, New. I'm going to pick that inch template again, stick inch, or the default template if you're working at home. And again, we're going to make a rectangle from a sketch on the top plane. I'm going to snap to my 0 point of WCS and go to the right, and then throw down dimensions. So again, the vertical is 3.75. Might as well stay consistent. And then the horizontal is going to be 4 inches. That can't be right. Can it? I guess we'll find out. Yeah, I've made this mistake before. that's why I'm looking at it. I'm like, wait a minute, that's right. So let's make this a 4.5 inch stock block. I'm sorry. So 3 3/4 in the vertical and 4 4.5 inch long. And we'll center that in the SolidWorks assembly later. Because yeah, I have made that mistake before. I was having a flashback because I was typing this. So we'll go 3.75 by 4.5. I'm going to modify my Word document right now. I'll have to change that in Blackboard later. And again, our thickness is going to be 0.46. So I'm going to exit the sketch, go to Features, Extrude, and then 0.46. I'm going to click OK, and then I will also change the color on this before I save it. Again, that's optional. When you have a bunch of gray parts, it's kind of nice to have different colors on these. So I'm going to do File, Save As. And I'm going to file my week 5 working directory and save this in the leg Op10 folder. And we'll call this Op10 stock. And again, I don't think we'll use this for Op10. Maybe we use it for Op20 because the Op10 kind of doesn't really need the stock block for that. But we'll have it when we want it. So after you save this we will go ahead and start to build the sub-assembly with the fixture, and then we'll do the parallels and the curve bite, and then you'll be ready to rock. By having all these files open and keeping them open, again, it's really easy to insert the parts into the main curve vise assembly. So I have switched to that view with the curve vise in it. And I'm going to go ahead and start inserting parts. I'm going to drop the fixture plate in first. So I'm going to go to Assembly, Insert Components, Insert Components, and then in the Open Documents tab, I have the fixture and the stock right there. So I'm going to grab the fixture first. I'm just going to drop one down, make sure I don't duplicate it by accident. I do not have the part open yet, so I'm going to have to go ahead and find the part by navigating to the folder and opening it. And then I will kind of walk around and make sure everybody's up to this step before we continue. So I'm going to browse, and I'm going to bring in the leg and drop that in as well. You don't okay with that? Okay. So I got Okay, perfect. Good. So yeah, so just go ahead and open up the first leg. Oh yeah. And it looks like, did you save? Okay. Stop. Yep. And then can you insert your that's fair enough. The only thing you'll want to do later is just all this stuff to be in that option. So you can click it where I go later if you want to. But it looks like file there. So these are all in the main leg thing instead of on, which is fine. You can try and move it. I think on your side, can you click it down and then try to rotate it? It depends on did you save your file? Go ahead, you can actually right click on this and open, and then open the file. Okay. Yeah, so we're missing. I'll come over and help you. You want to watch. They're not gonna after the assembly part. I'll let everybody know. You may have a second file. You see that you did somewhere else. Right. Here's what you can do. Hit cancel. If you go to the file, it shows you the last additional open reason that was one well then. There it is. Click now, the open file. So yeah, click on that. And I click no. And we should close that. Okay. So leave that out there because we don't got any long. Now, okay. That open region area is the white thing. Close that. You guys close the file. And go to browser. Oh, yeah. Well, right there. It's not open to that one. It's not up on that over and over. Okay, so let's do the mating part of this and see if this thing snaps together the way it's supposed to. So I'm going to start by aligning it to the holes, because sometimes if you try to do mate going from like 90 degrees, sometimes it gets kind of wonky. So I'm going to do the bottom of the part to the top of the plate first, just to get it into the right orientation. So I'm going to click on mate. I'm going to do the bottom of my leg part and the top of the plate that we built. Then I'm going to do the 5/8 pin and the 5/8 hole. And then I'm going to swing this around. So you got to do this one the right way. So it has to be, for me, it has to be this hole to swing this out the right direction. So I'm going to grab the hole and then get the pin. And if we have our dimensions lined up, which it doesn't look like it is, it should rotate around, but I don't think it likes something. Either that or I went too quick. No, just the concentric. So why won't this swing around? The other thing we could do is just make it parallel. So if I make the bottom of this leg parallel with that, that actually works too. It may just be a rounding error. Maybe we won't pick the two holes. Because, you know, even if you're off by a thou and you try to make those two things together, even the rounding error, it won't let it do it. So this is probably the better way to do it. Let me show you how it works. So again, we're rotating around that center dowel there. I go to mate. So now the bottom of the leg and then the bottom of our work fixture plate. It's right now it's doing the opposite alignment than what we want. So if you come down here to mate alignment and change it to aligned, then it'll flip it over. And if you notice, if you zoom in on this thing after you do the mate, it looks like we're there. You know what I mean? It's just a conflict. Sometimes you do two holes like that, it doesn't want to mate properly. In the real world, that would have worked out fine. So good. All right. I'll put it that. At least not that. So the only thing that we're missing as far as the subassembly goes is the fastener. And I mean, we don't really have to, but we got plenty of time here. It's going pretty smoothly. So let's go ahead and use the library. And it's been a while since I did this. So I think it's the smart fasteners. Let's check that out. So in the side of assembly, I'm going to click on smart fasteners. No. Cancel. What am I looking for? I'm looking for, oh, the parts library. Design library? Design library. Yeah, there's a toolbox. Okay. So on the left-hand side, there's like an icon under the house icon with like 4 books. Inside of there is a toolbox. And that's where we can design a fastener for ourselves. So I'm going to click on Toolbox. I believe we want ANSI inch. And then inside of the ANSI inch folder, we have all these nice nuts and bolts and things like that that come with the software. So again, there's no Z consideration or no clearance issues with this, so we can have any kind of headed bolt we want. I'm kind of envisioning just a socket head cap screw with like a nylon washer underneath it. I'm not going to do a nylon washer. We'll just get the screw in here and be done with it. But that's kind of what I'm thinking in the top, you know, just in my own head right now. So we'll go to bolts and screws. we will go to, where are we? I want socket head screws. So towards the bottom, second row from the bottom, socket head screws. And then we'll do a socket head cap screw. That's my favorite. We could do a shoulder bolt or something like that if we wanted to, but I'm not getting super fancy. Socket head cap screw. Now, in order to find it, if I remember correctly, all you need to do is click the socket head cap screw icon and drag it out into the assembly and drop it. And then once you do that, it's going to ask you to define what the size is. This is a really cool tool. I like this a lot. The problem with doing this, like if you're building machinery, is that the library starts to get kind of slow if you're adding a bunch of these things, and you can crash your computer really easily. So we're going to change the size to 3/8/16. And then over on the left-hand side, we're looking for a length. So we know at a minimum, we want to go 0.46. That's through the part. We don't really necessarily want to go all the way through the plate. So maybe we just do a 1-inch bolt. So I'll change the length to 1 inch. That's from the bottom of the head. So that's actually like a 1-inch thread from underneath the head. And then I think outside of this, we just click OK, and then we'll do our mating outside of this command after we configure it. So we'll click OK. Oh, it's actually asking me to insert again, huh? Oh, so we can actually, at this point, we can actually just click the hole we want to insert this in. That's kind of cool. I think that's new. I don't think I've ever, well, no, actually I used to do that too. So I'm just going to snap to that hole that we have made. And you see that you got a little black like snap line there. We'll drop that in place. And it happens automatically. That's pretty sweet. So I think we're all set. If I hit enter, we should be done with that. Perfect. I'm still attached. I'm going to hit escape too, because I think, yeah, there we go. I have one extra bolt there. I'm just going to delete the one that's in the air. We don't need that. Yes. Cool. There we go. So your assembly should look something like that. Your sub-assembly, I mean. Everybody happy with that? Excellent. This is like the most common work fixture type troubleshooting thing that people do. It's just a simple plate with holes, and you use whatever features are on there to lock it in place. Your order of operations obviously becomes important when you're doing this because you need those features first before you can actually use them to work holes. So that's always something to keep in mind. At this point, I'm going to save it and then just think about my my parallels for a second here. So we got a 1-inch plate, and I think the depth of the vise is 1.6, if I remember correctly. So if we do anything under like a 1/2 inch size, let me just double check this, we should be fine. 1.74 is our depth. So we want to sink that fixture in a decent amount. So I don't know, let's do a 3/8 little parallel, I guess. Something like that. So I'm just gonna draw mine because I know I don't have a 3/8 parallel in here. I think I got some small ones, but not that small. So I'll go up to File and New. It's real easy to draw one up. I'm gonna click OK on the inch template again. I'll sketch from the front plane this time. Doesn't really matter, really. I'll draw a rectangle. And then, like I said, let's do, oh no, 3/8 is way too small. What the hell am I thinking? 1 inch plus, let's do a 1-inch parallel. I think that'll work. 1-inch parallel. If you already have one that size, feel free to grab it, but I know I don't have a library. And then the vise is 6 inches wide, so I do a 6-inch long parallel when I do this. And I'll change the color again. Forget what I'm using now for colors. Oops. Oh, I didn't extrude it yet. That's why it's not doing it. And we'll extrude it a 1/8 of an inch, 0.125. There we go. And you can save this in that Op10 folder, or if you have a fixture folder with all these things in it, you can just save it in there and then bring it in afterwards. For me, I'm just going to save it in that Op10 folder that we're building, just in case I need to change the height. Kind of doing this on the fly with you guys myself too. I kind of enjoy doing it like this. And then per usual, we'll go ahead and assemble the parallels into the vise like we have been. I'll talk through it, but I know a lot of you are probably moving ahead, so feel free to keep going. I'm going to insert the parallel I just drew. And that should get us where we want to be because the part's going to be sticking up above all that stuff anyways too. So I need 2 of these. I'm going to insert 2. And I'm going to make them to the vise first before I do the fixture plate. It's a little bit easier to do the parallels first sometimes. And you need 3 mates to fully define to remove all of their degrees of freedom. And you know you got it locked in place when you can exit the mate command and click and drag, and it's attached to either the vise or the movable jaw. So in my case, the first one I did was the movable jaw, and it can't come loose. Then I'll do the second one. I think everybody's getting the hang of this by now. And then once your parallels are in place, now we can go ahead and attach the work fixture to the parallels. Starting with the base plate, again, because it's easier to orient itself in the Z the first time than trying to do these side areas first. So I do that first. Then I will do the side faces. I will attach the plate to the fixed part of the jaw on the vise. To make it a little bit easier on myself, I'll then move the movable jaw kind of out of the way a little bit so you can see the surface that you need to select. And then I will go ahead and click on that side face and attach that to the plate. So when you're done, you've got a really nice looking assembly here, especially if you modify some of the colors and stuff like that. This looks really good. So I'll save that and walk around. We'll spend a few minutes, just making sure everybody's up to speed on stuff. So again, we did is we just built the Op20 really. So I kind of screwed one. Because Op10 is going to be just drilling square. I just realized that now. You're okay with it now, right? Yeah. Yep, you got it. A little bit farther. Oh yeah, there you go. Perfect. Yeah, that's fine. It doesn't really matter because we're going to be cutting on the outside a little bit here. You want to be a little bit. Perfect. Yeah. So let me think about. I was going to, but I don't think we're good. I think what we're going to do is we'll build another operation. Yeah, I screwed up a little bit because I was calling this Op10 and this is actually Op20. So I kind of screwed it up. Give me a second. We'll get Steve up here and then. So you're able to get okay. Good. Awesome. So you got, okay, so go into the library, which is the book looking icon. Right there, yeah. Toolbox. And then when you scroll, actually into the double click. And then bolt and screws. Scroll down to the socket head screws. And then socket head caps. So if you click on that, right, it's workspace here. Perfect. You can allow it to define it. So we did a 3/8-16. You can actually then you guys look length. So the length is 1 inch. And then okay. And now it's asking you to select a hole you want to put in. Please go over and go that hole on it. Cool. So it looks like that's wrong. That's okay. Leave it like that. Oh no, it's right there. No, it's right at the edge. You're right. No, that's perfect. Good. So go ahead and hit enter, and that'll fix it. And then hit escape to get rid of that icon. And shut. Oh, good. Yeah, yeah. 1 inch parallel. Yep, you got it. Or 1/4 inch, yeah, whatever. Usually they're 1/4 inch. Yeah, and they're 6 inches long. So that's cool. Yeah, so like I was saying, I actually kind of screwed up because we built the OP20 assembly, so we kind of did it backwards. I would say we could rename the file folder at the end, but I don't think I want to do that because it might screw people up if you don't do it the right way. It can mess stuff up. So we'll do it. We'll do it a little backwards. You know, no big deal. I'll just start calling it instead of OP10. I'll start calling it the fixturing assembly. So I started with this one first because it was the most complicated, right? The other one that we will be doing is just literally just drilling the holes and holding that square plate in the vise. So we can. I'm not even going to have us set that up. Let's do this real easy. So what we'll do in Mastercam is we'll just we'll insert the solid parts and make a stock block and just drill the holes based off of that. And then we'll insert this off to the side for our OP20. Okay. And since we're walking through it, you know, ourselves, we can do whatever the hell we want. So we'll just pivot a little bit because we don't have to make a solid assembly for this. So we'll save this. And Steve, you got plenty of time to keep working on that, and I'll just kind of talk through what we're going to do now. So we'll minimize this for now. We'll keep this in our back pocket. And we're going to use some of our Cam 1 skills and just do a lot of the simple, easy stuff in Mastercam here using our stock setup, the rectangular stock setup. And we will talk about the machine group versus toolpath group again, okay? So we're going to use, in this case, I'm going to set up the stock twice. So we're going to use a machine group, okay? When you use a machine group, basically that means it's going to create 2 separate post files when you generate your G code, okay? It doesn't necessarily have to be the same machine, but that usually means it might be a machine change. In this case, because I want to have the stock set up for the simple drilling, we'll mix and match. So we'll do a simple wireframe stock for machine group 1. Machine group 2 will be where we use that assembly and our solid stock, and we'll use it that way too. Okay. And if we have time today too, I may have you create your own view sheet. That's the next step in the process I usually introduce yourself to. So I know we saw it last week, but I didn't have you make it as part of the project. I might have you start doing that going forward. And then we'll start talking about using Verify and the stock stuff that we were looking at last week. We'll start adding that next week. Did you help with that? You're good? Okay. Okay. So I'm in Mastercam, and I'm going to go ahead and load up that first machine group. Okay. So I'm going to go up to the machine tab, and I'm going to load in the mill 3X. Okay. I might just go ahead and do this twice and build our structure now so that we have everything set up. So for machine group 1, the toolpath group underneath that one, we're going to go ahead and rename that and call it Op10. And one thing we haven't done before, you can also rename the machine group. So I'm actually going to go up to the machine group and rename that as well. And we'll call that just Op10 machine group. Or Op10 machine, yeah, Op10 machine group. Why not? Okay. So as we talked about, we're going to add a second machine group after that. I'm just going to follow the same procedure. I'm going to go up to machine, mill, and then bring in the 3-axis again. So that drops a new one underneath. We'll take the machine group and rename that first. We'll call that Op20 machine group. And the toolpath group under that will just be Op10 or Op20. Once you do that, you'll notice that the red insert flag is currently in machine group in that Op20 group. That's the active one. We want to bring that back up into Op10 because we're going to work there first. And then once that's under Op10, I'm going to go ahead and save the file. And you can put that anywhere in week 5, whatever works for you. I'm just going to do my last name underscore and then leg Mastercam. And if we have enough time to, I will also talk about maybe posting some code. Maybe we'll post some code today. We haven't done that yet. Maybe I need to do it on an old file because I'm not really planning on walking through all the Mastercam stuff with you. I'm kind of going to leave you after we finish setting this up to do the rest. So we're not going to use the stock block. So if you just delete the stock block out of there for now, we'll come back to it later. Yeah, that's perfect. Yep, that's perfect. Yeah, the orientation. No, that looks good. No, I like it. Just save this and then you can minimize it. And we'll screw around with the stock setup after we get the job. I'll do it there. Don't worry about it. We'll do it later. And then just open a fresh Mastercam, and we'll get that caught up. So we're gonna be, we're used to merging multiple solids in here, right? So we're gonna do this a couple times. Like I mentioned, I'm just gonna bring in the leg solid body, pretend that we have the Kurt Weiss set up in here, and just do the leg, and then build a 2D wireframe stock around it, and just drill the holes. So that'll be our Op10. We'll also turn that into, we'll do the stocks. What are we? What is it? It's toolpaths. Maybe we'll do some of the. Why can't I'm drawing a blank. We'll do a stock model at the end too, and see if we can get that to work for the next machine group. Maybe if we see if we can do it. So inside of Mastercam, I am going to start by using the default top plane, but we'll make a new one after we get the part inserted. Okay, so I'm just making sure I have my orientation right. I'm going to go up to File, Merge, and I'm going to bring in the leg solid file. Remember, you got to change the filter in the bottom right-hand corner to all files. Otherwise, you may not be seeing what's actually in your folder as you're working on it. And when we bring that leg.solid part in, I'm going to first confirm what the orientation is, right? And it actually looks like we're in good shape. I'm going to click OK. And if I do top, it's actually in the right orientation for a change. How do you like that? Not bad. So there is no 90-degree move to make on this one. Okay. So we are going to move the parts to the upper left-hand corner, which means we do have to do a little bit of, we could either draw, but I'm actually going to just offset this using the X, Y, and Z coordinates to show you a different way of doing this rather than drawing reference geometry. So what I'm going to do is I'm going to use the move to origin command to get me to the bottom left-hand corner, and then we'll change the Z height on it after it manually, after we do that. So let's go ahead and go to wireframe. No, where am I going? Transform, sorry. Transform, move to origin. And again, I'm going to click on this point here because that's typically the bottom left-hand corner. But again, that's the wrong Z level, so that's what we'll modify next. So we'll click on that. Okay. That brings us to the origin. And this is where you can first sequence. So now we go to form, move forward, and put 11. All right. So if we go to the planes tab next, you know, we can see that, yes, top is perfect what we want, right? But you see, we can't modify that Z origin because you can't modify the default planes, right? Real easy to get around that. So we're going to right click on top. We're going to hit duplicate. That creates a duplicate plane on the bottom. We're going to rename this. This is going to become our op10 underscore G54. And now you'll notice in the bottom left-hand corner, we can modify the origin manually, X, Y, and Z. So in this case, all we need to do is reference the print and see the depth of that channel or the depth of that cut. And then we can offset by that distance to bring it up rather than have to draw geometry. So according to that blueprint, the depth is 200. Perfect. Thank you. So we want to go up, right? So that's a positive direction. So if we type 0.200 in the Z, it should throw our G54 up to the top of the part now. It still shows you the original top plane, that green one is what you're seeing. It's kind of clunky. I don't like that way that works, but the colored one with the X, Y, and Z axes is the G54, so I know that's correct. When you hit the equals button on that op10 G54, the other one should go away. You see that? So once you make the other one active, it just shows you the active one. So we could have drawn in that case, but if we have an easy print dimension to work off of, sometimes it's easier to do it. So we'll do a file save. I must have saved that. Just do file save. I'm going to right click on top. So that looks perfect, right? Not bad. So as I said, you know, we decided we're not making an assembly for this. We're going to pretend it's in the device already. We probably should have oriented it the other way. It would have been easier to put it in that direction, but not a big deal. So in order to build the stock block the way we want, well, first let's go to levels, sorry. So we haven't renamed our solid yet. So if we go to the levels tab, we only have one active right now, so it makes it really easy to modify. So I'm just gonna call this op10 solid part. You can call it op10 support leg or something like that if you want to. And I'm gonna right click and clear colors to get rid of the purple. And now we can go back into toolpath and set up our basic stock just for drilling purposes. If you remember from last year, we haven't done it this year, I don't think yet. We're going to go into stock setup, and we're just going to manually type in the dimensions, and then we'll offset the origin so that it's centered on the part. So stock setup, we're going to change the stock plane from top to the op10 G54. That should be, the stock plane should be the plane that we're working on, the G54. In the Y, X, and Z, we kind of got to pay attention here. So the Y is going to be our 6-inch dimension, I believe. The X is going to be our 4-inch dimension. And then our Z, oh, I'm sorry, no, sorry, totally wrong. 4.5 is the Y. I was calling it the plate. The X is 3.75. And the Z is 1, or 0.46, sorry, 0.46. I got that plate dimension stuck in my head. I'm going to make sure display is checked, and I'm going to exit the command to look it out and make sure you can stay into it if you want to. I'm just going to exit because I want to see the preview and see if that looks correct. And yeah, the orientation is good, and now we just got to muck around with the origin a little bit. So I'm going to go to stock setup. I'm going to start by just changing the origin from the center of the block to the bottom or the top left-hand corner. And again, clicking OK, just watching the preview just to kind of see if this makes sense, right? I like to work incrementally. There's nothing saying you can't do it differently, but I just find if you modify 3 things at once and something is wrong, it's hard to diagnose which one's wrong. So I try to do it step by step. So now looking at the print, we can do some more basic math. We just double check this. Okay, good. So the x-axis here, right? So the x-axis, the part is 3.5, and we said the stock was 4. No, sorry, 3 3/4. So that means we have a 1/4 inch right now on the side. If we want to center that, we need to shift it 1/8 of an inch in the other direction. So let's make that move first. I'm going to go to stock setup. And in the X, we want to go to the left. So that's going to be a negative move. So we'll do negative 0.125. And I'm going to, again, exit and watch the preview here. Excellent. So that looks good. So now we have a 1/4 inch on the top, I believe. You said the whole thing was 4 1/4 inch long, right?
Yeah.
Okay. So that means we have a 4.5 inch block. So same deal. We want to offset by 1/8 of an inch. And that's going to be in the Y. So this time, you know, we want to bring the stock block down. So again, we're going to be doing another negative dimension, negative 0.125. And that should get us there. Looks good to me. Perfect. Okay. So, I mean, marginally faster than building an assembly, right? It probably takes 5 minutes, whatever. Good deal.
Keeping the thickness in the part.
Yes, yes. So that's why we had to do the blade, because I thought I could strain that thickness there, so we had to put it up. This would have been real simple if I could get in the part. Yes, this is perfect. So get the blade turned on. So X and Y are negative 1/8, negative 0.125. And that will orient the stock so that it is centered on when you click OK, now you should be looking at. Cool. Stock setup. We also have to move the origin from here to the center of the corner. Because our dimensions are based off of this corner, so we want to move this zero. Yeah, you can just click on this one over here in the left. And you want the top of it actually. Yeah. So that changes where these dimensions are going. That's a big deal. That changes. So when you click on it. So now there's your new line. Great. Nice job, everybody. Very good. So again, we're going to save this. And since the operations are very simple, you know, we're not going to do the manufacturing right now. The next thing we're going to do is we're going to merge in the other assembly and position that just to make sure everybody has that baseline before we start. So again, when you go to drill this, you can just follow the Word document. It's literally spot, drill, ring, drill. So you're going to have 4 operations on this one, okay? For the next one, we are going to put the stock in the right position in the solid file first, and then we will import, we'll merge that file into the master camp. Okay. So let's save this. I'm going to go back to our SolidWorks assembly. And this is actually going to be nice because now we know what those offsets need to be too. So when we mate, we know we can do those 1/8" mates to get this all lined up too. So we kind of established that already. So I'm going to go to insert components, and I'm going to insert the stock block. You may already have it. Okay. If you don't have it, go ahead and drop it in. And I'm going to start again by establishing the Z. So I'm going to mate the bottom of the stock block to the top of the plate itself, the fixture plate. Then I'm going to go ahead and mate it to the back of the part this time. And that's going to be a distance mate. So once you've established that it's parallel and coincident, on the left-hand side, you're going to click on the distance command, and that should be 0.125 for what we've just figured out in the other file. In my case, the dimension's wrong, right? It's going into the part instead of back the other way. So I'm going to click on flip dimension. It looks kind of funky when you're doing it here. So just try to be cognizant of what you're clicking on. I'm going to click OK. And then I've actually got to move my block out of the way a little bit to be able to see both edges that I want. So now I'm going to mate the other side of the block to the side of the part. And then again, that's going to be a distance 0.125. In my case, both times they were wrong in both directions. So I had to flip it both times. But in the end, you should look something like that, exactly like the way it is in Mastercam. And it'll look a lot nicer when you change the transparency to see-through for the stock. It'll look a lot less. Okay. I think that is excellent. So once you have those 2 1/8" distance mates in there, you click OK. And again, so the transparency part of this, if we go and we left click on the stock block, you get a tooltip pop out. And in the top row, there is an eye-looking icon with a part behind it that says change transparency. You can just left click on that and turn the transparency off. Or see-through. It still looks a little funky, but overall, this looks really good. I'm really happy with that. So we'll save this. And yes, that good. So now, make sure you save it because we're going to merge it right away, right? So if you don't save in between, you wouldn't actually get the stock block if you go to merge it right now. So that's excellent. We'll drop this down, minimize it, and go into Mastercam. And now we're going to do that offset trick that we have been doing. So again, I used to do 12 inches, just so they're not overlapping. If you establish your WCS G54 and 55 right, it doesn't matter where in space you put these things. So just try to do whatever makes sense to you, whatever helps you stay organized in your head. I'm going to turn off the level for that Op10 solid part. Pretend it's not there. And if we really want to get into it, you know, if I don't want to see that stock outline, take the red insert flag and drop it into the machine 20 group. And that will make it so that that stock block is no longer active too. So those red dashes go away. Okay. That's one thing to remember that's important when you're backplotting or verifying these, is if the red insert flag is not in the right spot, you could go to verify Op10 and it'll use the Op20 stock. You know what I mean? It'll use the wrong stock. So when you're checking stuff and you got multiple machine groups, you want to make sure that that red flag is in the proper group when you're verifying. So I will now go up to File and then Merge. And I'm going to grab my Op10 air quotes assembly that we just made. So simple Kurt Weiss, I didn't rename anything. I'll open it. And then that should have all of our parts in it. So it should look like that when you go to bring it in. Your color scheme won't show up until we enter it and then do clear colors. So that's okay, it'll come back in. Again, I don't like to rotate and flip or do whatever else in this command. I like to hit OK and then use dynamic transform. So I'm going to right click and look at the top view and just confirm that I'm out of whack. And we are, right? We're looking at the front. So I'm going to go ahead and do a pick box and make sure I get everything on the solid for the assembly. And then we're going to go up to transform dynamic. Again, I'm only doing my rotation moves incrementally, so I kind of just rotate to the left a little bit so I can see the full gnomon. I drop it down anywhere in space. I'm going to rotate up between the Y and Z, and that's going to be a positive 90-degree move. Enter twice, locks it in. Green checkbox finishes the command. So now when I right-click top, we're looking at the right orientation. Now I'm going to do the same trick, but this time I'm trying to figure out what our origin point should be for this. I almost want to indicate off like the top of the pin or something and like put the WCS on the center of that hole up here. Just because it's most of the dimensions are coming from that datum, you know what I mean? So that's the important part of this feature here. I know I've got the print on. So this center line, there's a lot of emphasis on this center line. So maybe what we could have done was actually made the pin stick up a little bit higher so that it'd be easier to get, and then we could have probed off of that to get the center point of that. Let's just play around with that idea for now. So we're going to make our G55 point the center of the pin because we can do that. Just screw it. So I'm going to do move to origin, and I'm going to try and get it to go to the default plane, and then we'll shift it by the 12. So I'm going to click on move to origin, and I want to see if I can snap to the top, to the center of this thing. You may have to zoom in to get it. But we can get it, it's not too bad. So I can get the center of that. when I click on it, making sure it's not the quadrant, it moves to the center of my pin, right? That's good. Now, this is just so that we can establish like a baseline. So right now we're right on top of all the other stuff. If I want to go by 12 inches, which is what I normally do, if I want to shift over 12, now I can go to dynamic. I'm going to select my full assembly again. I'm going to click OK. Or hit enter. There you go. And now instead of doing a rotate move, right, we're just going to click on the x-axis in this case. And I'm going to actually snap to something because I'm trying to move it like just a clean 12 inches. So I don't want to put it in space. I'm going to click on probably the bottom left-hand corner of the vise. So I'll establish that as my like initial movement point. And then I'll click on that x-axis. And we can just type in, I think actually 12 is probably too much. Let's do 24 inches because that'll get us clear of everything else. So 24 inches to the right. Okay. And again, this is just to keep it clean. We're not affecting the code, or this has nothing to do with the machining thing. This is just how we like to set our Mastercam files up. Now that we've done that, now we can basically create our new plane that we're going to use. Okay. I'm going to right-click Clear Colors. Was everybody able to make that move? Looks like everybody was able to do it, right? Okay. So now what we'll do is we'll go to planes. We'll duplicate top again because our orientation is still the same, right? Our Z is still going to be going up. The only thing we're changing is our X and Y. So we'll duplicate top again. We'll rename this top 20 G55. And rather than, I guess actually we could just, I think we just could have typed in 24 inches here if we wanted to. If we want to be cheap. I was going to say we should just click on the cursor and do it, but actually if we go positive 24 inches from the origin, that actually puts us dead nuts just because of the way we set it up. So if you put the X origin of 24 inches, that throws it right into the center of that. Now this is dangerous, right? We're going based off of the moves that we made. If you wanted to be exactly sure where this was, you probably would want to click on the pin again on the center of it, but I'm fairly confident this works out pretty good. And again, so these X, Y, and Z origins here don't have any bearing on what your WCS actually is on the machine, right? The machine's still going to be 0, 0, 0. This is just kind of a reference point for us. And when I hit the equal sign, that becomes active. It brings all the datums over. And there's our G view. So now I can save this. And I'm going to go into my levels and just turn everything else on. We can just kind of see. So there's our part over there for the drilling, hanging out in space by itself. Just you can save this as a regular. There's no operation number associated with this file because we're doing it all in one. So you can just call it leg. You know what I mean? If you're going to have more than one Mastercam file, then yeah, you'd probably want to delineate that somehow. So that's good. So all I did was turn on that level, and I was coming in here anyways because now we need to rename our levels. Okay. So like I did last week, you turn one off and establish what that is, and then you kind of rename and work your way down the list. So I'm going to look at the assembly that we just brought in. I'm going to turn off number 2. Okay, so that's my fixed jaw, or fixed base, or vice base. And again, our numbers are kind of out of whack, so call these op 20. I know I kind of screwed up on the SolidWorks side of things, unfortunately, with the naming convention. So op 20 Kurt Weiss base. And let's just walk down the list and rename everything. So this is op 20, movable jaw. Number 4 is the op 20 plate, or the base fixture plate. There's the solid part. While I'm doing this, Matt, how are you making out? Okay over there?
Yes, I'm doing fine, thanks.
Okay, good. Okay, great. Figured I'd check in with you.
Appreciate it.
One is parallel. And then there's the op 20 solid stock. So your level should look something like that. Everything related to op 20 has the op 20 prefix, right? Makes it easy to look at. It'll be even easier when we do our view sheets, because then you won't need to be too concerned about this as much, because you can save the view sheet with whatever you want turned on, and that never forgets it. So you switch back and forth, which is pretty nice. So I'm going to go ahead and save this. And now we'll just set up our solid stock, and then we can take a 5-minute break, and then we can, you guys can basically start working on the tool paths. Should be pretty good. I don't think there'll be anything else to do with this, really. And I could lecture through a tool path, but I think I'm boring you enough as it is. You guys can do that on your own. So to do the solid stock, again, I'm just going to go back to tool paths, make sure my op 20 machine group is the active one, and then I'm going to go into that op 20 stock setup. We're going to have to change the stock plane again. So instead of the stock plane being top, we want this to be G55. And then we're going to go ahead and do a bounding box and select the solid stock block that we had brought in the SolidWorks file. We then click OK. Come on. Well, I got more than one piece selected. I think something happened here. Let me clear colors. You shouldn't do a pick box because you only want that one block. It's just this one stock block there. So let me try that again. Stock setup. Oh, maybe we just need to do a solid instead of the bounding box. Solid mesh, sorry. And then the cursor, then the stock block, then you click OK. There we go. I did not click on display, so if you want to be able to see it, make sure you click on display. And then I'll change that to solid because that's why that's the whole reason we did this. We want to keep a solid block. Once you have that established, you can go into levels and turn off the actual solid block. Why is it not showing up though? Oh, it's way the hell over there. What's going on here? Being funky. May need to mess with the origin here. I thought we did rectangular and then bounding box. I thought that's what we were doing last time. It worked for you? Okay, I don't know why it didn't work for me the first time, but yeah, that's the way we want to do it. I'm going to turn the solid stock back on. The actual piece, I mean. Stock setup, rectangular, solid, bounding box. Click on that solid. Huh, it's not letting me,
The end selection is not how long.
yeah. I just hit enter, I guess. Oh yeah, okay. So the end selection, yeah, something. So if it wants you to click the checkbox, hit enter and it'll bypass it. It must have been minimized somewhere on my screen. And then we click OK. Thank you, sir. Now it'll look better when I turn that off. So there you go. So there's the color. Okay. It looks a little funky on the top because we're line on line. Unfortunately, Mesh doesn't deal with that very well. But now again, so if we go to top view and I save this, and you go back to toolpath and switch back and forth between machine groups, you'll see that your stock shifts depending on which group you're working in. Okay, pretty cool. I like it a lot. So you are basically all set to manufacture. So again, make Op10 machine group active. After your machining is completed, maybe around 8:15 as a group, we will create the view sheet together, and then we'll save it, and then you guys will actually be done with this whole project tonight. And then you can just do the base plate at home, at your leisure, whenever you get a free half hour. So this actually went pretty smoothly. I'm happy with this. You can expect to see more of this type of work being thrown at you going forward. And, eventually I will flip a switch and say, you develop the fixture. And I will help to guide you in certain directions if I see you're going too far one way or the other. But, I won't always give you the specs like this going forward. So let's take a 5-minute break and come back at 7:15 because I need to run to the restroom. So either way, I got to take a break. So we'll start back up in about 5 minutes. And just make sure you saved all your stuff. Your SolidWorks should be saved too, but go ahead and just double check. And I will be right back. Okay. So yeah, basically, we'll stay open lab for like about an hour, like I said, so you guys can work on the project. And then we'll spend the last 15 minutes doing the view sheets. If everybody finishes a little bit earlier than that, we can always start the view sheets earlier. Does anybody have any questions about any of the stuff we were doing as we were working through it, or pretty comfortable with it for now?
Good so far.
Pretty cool. Good. Great. Glad to hear it. Oh, and as of yesterday, I had everything graded. So the other thing you can do too is if you didn't happen to get full points on something, remember to go back in and bump it up. Normally it's something stupid, like one or 2 points can get thrown back at you pretty easily. Midterms will be coming up. While I'm thinking about it here. So March 15th we're off. And then March 25th is the midterm. So just keep in mind that between now and the end of the month, basically, you're going to want to make sure you're all caught up. Because your midterm grade will reflect whatever you have done. There's always a few students who are a little bit behind at the midterm and they're trying to rush to the midterm grades and like junk. So just make sure that you try to stay caught up. Yeah.
Oh, so you can use any size spot drill that's bigger than a quarter, you just have to, make the size a quarter inch. So you can use a half inch in quarter three if you want. Make that. Yes, correct. Yep, exactly. Yep, yep. And that way you can do the money. Yep, got it. Okay, so you can go back into, you can go back into School pass. Go home. But it looks like you're okay. That's you. You may want to cycle through all this. But I wouldn't worry about tax going on the side. There's no harm in it. But, I think, I wanted to find you have technique, read cycle, and the same thing, yeah, you want to switch that. For read, you definitely don't want to do that, because you want to. Doesn't make this we should get at all. Yeah. Feel pretty good. So, were you able to do last week at all? Or you still gonna follow? I get okay. That's I'm done grading. I think that's right away. That's great.
I wish it was. The camper web. So, it actually, there's usually like this one here and then you. Something back. Yeah, it depends if it's drawn in. If it's drawn in, and you select the bottom of the chamfer, you're supposed to put in 001 as the width. And then you put in, then when you go into, stick down here, you can put 1.001 wall to offset it, right, you know what I mean? For, when it's not drawn in, it looks like you got it right, both dimensions. Then I have this right here, so basically, go down a little bit. Yeah, that's basically now where you are. Right. Right, they don't have like the tip. Yeah, yeah. Yeah, change the width to like 1.01. It may just be that. Um, maybe. Well, that's the first year. Yeah, but I didn't really check it, you know what I mean? To me, 30,000 out a lot. What's it look like in the solitaire? Maybe. Well, I haven't set the 10 right now. Maybe. You just want to get this. That would be good. Yeah. Yeah, I'm not gonna. At some point, I'd like to take over. Copper bottom. That's really. I think we put 30 on Nelson, and that looks pretty perfect. Could be. That's 30. Yeah. For what is it there?
Sure.
Just the standard drill cycle is, yeah. It'd be great if there was a cycle for me, but there isn't one. Or it's basically drill counter bolts as well. Obviously, I have like, but it's old, but, I still think that's what time we're on that is. No, it's definitely not second. It's like, understood second or something like that.
And then the speed gets slowed down by quite a bit too. But that should come in with the reamer itself.
Let me see if I can look that up.
Yeah, apparently it's seconds. It's supposed to be seconds. I guess the important part is that depending on the controller, it looks like when you do add a dwell time to that, it actually throws a different G code too. G81. I'd be interested to post that and see how it comes out. Hmm.
Yeah, if you made it thought one.
Yeah, so I figured these are the right things for Mike and we want. We're just going. Yeah, yeah. Yeah, we're having to depend on it, but it's really the way to get it.
Which kind of thing. Yeah. That's good. I know the boat you're in, yeah. So that means you have from inside, but from outside, you're saying. Yeah, it's constrained by the rectangle. So if you do from outside, it'll take some kind of power. Yeah, yeah. Are you using Consort? Okay, so, take a look at. So that absolute 775. Okay, so you may have to run plane too. So the plane should be G56 or G5, which is correct. So if you go to linking parameters again and click on the depth button, and then click on the part, is that what you did? To get that 700. All right, so that's how it's in the plane. So click OK here, and then go into the plane. Yeah, so you see how it's in the bottom of the pin, it looks like, if you rotate a little bit. See that? So, move that. Oh, yeah, 'cause you know what? Well, the other thing too is my Z weight was wrong on top. So if you have the Z on the top of the pin, it's off by a little bit. So what you want to do is go ahead and click the first one. Zoom way in and see if you can get the seam of where the hole is. So like not on the pin, but just like. Here you go, that's what you want. So that will change your dynamic. So you have to go into your tool path now and probably reset your set. But it won't take you long. So regen those three commands. Here comes the action. You can click on it. Yeah, exactly. Yeah. Sometimes they change on the Mac and sometimes they just have to be endpoint that you do. There you go, that matches the correct dimension. There you go.
I just caught something. So I originally told everybody to put their WCS on the pin, but I forgot that that pin's raised up a little bit. So if you didn't catch it, what you actually want to do is probably have the G55 point be on the top of the part, right? So when you actually do this, you actually want to grab like the seam of the circle that's on top. I'm not worried about it now, but just if you're looking at the print dimensions, like in your linking parameters, you might notice that they're off by a little bit. And that's because our top is actually on top of here by accident, and really we should be down here. If you want to fix it before you submit it, go for it. The only thing you would need to do is probably just have to go in and regenerate your parameters and just review your linking parameter depth and make sure they fix themselves. That was my fault. And in about 5 minutes, we'll set up our view and files. And then we can probably call it an evening. Everyone can take off. It won't take us 15 minutes to do the view sheet.
Do I need to have an operation? Is that why mine are showing up? Interesting.
So, that is, so you see a small arrow pointing inwards. That is the opposite of what you want. Sorry, Yep. 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 Yeah. So that means that the cutting side is on the left. Sure. It does. You play it. Okay, yeah, so it's still. I believe it might. Oh, yeah, you got the surface, yes. So instead of a surface, get the line, so let's see, you got to move, right? So just grab the, inside line, yep, yep. And. Oh, no. Put that on the page.
All right, go to partial. You click at the. So now click at the start of the chain. So take a corner. So like some flat. Yep, yep. And then go. Try to move again. And then pick the same top surface selection. It, try that. So swap the side out. That's right. There. Yeah, so it didn't like. So what I think it was trying to do is you had the surface picked, right? So it was seeing this thin strip of material, and that end mill's not big enough to fit in that. So it kicked it over here because it could fit on this side, but when you try to kick it over here, it was trying to fit in between that small swath and it was. So I think this. Normally contours are just, you just want to pick like a dot line, just follow the line. So sometimes solid contours, it's just not working on. That's what happened like a wireframe. Sometimes helps you can switch to a wireframe. So I have an interesting thing, and it looks like everybody else does too. For some reason, we're not getting view sheets. You see that in the bottom, like we had in the past? Normally you have like a strip on the bottom with the view sheet. And I'm wondering if it's having two machine groups that food doesn't. It should, but it's not showing up, right? I'm not crazy. Yeah, usually it's usually right there. If I go into a new file, well, maybe if I do a new file, I just noticed that when I was looking at it. I'm wondering if it doesn't have the ability to do like it's view sheets across machine groups. I think that's what the issue is. No, because it's not showing up here either. Huh. I don't know why it's doing that.
I mean, like,
Settings, view sheets, settings. Let me open last week's stuff. I'm so confused. Well, we're gonna hold off on doing the view sheets until I figure out why that toolbar's missing. That is so bizarre. Must be some way to turn that back on. Oh, okay. Huh, I've never seen that before. If you go to view, the view tab in Mastercam, all the way to the right-hand side, there's a view sheet area, and there's an on and off button there. So I don't know if maybe Mastercam got updated and that's the deal or what, but yeah, so if you turn that on and off, then you get your view sheets, and then you can do new view sheets there. We'll play with it another day. We only got 5 minutes now, but I'll remember that.
That's weird. It did not do that last week. It was, when you go to submit the SolidWorks file, just, even though we have the operations mixed up, just submit the solid, you would, as you would normally. No, I'm not gonna, wait for that, you won't intervene even.
I had us all screwed up doing that today.
That's great that everybody pretty much got it all done now.
Thanks for a light week.
Hey, Sean,
Yeah, Matt.
are we submitting the plate too?
Yes, yeah. So you do both this week. And as I mentioned earlier, the plate's pretty simple. So all I would do with that, and the instructions stay the same, is just assemble the curved vise and the part itself with some parallels, and then just go ahead and drill it. And don't worry about setting up stock or any of that stuff because it's not really needed.
Gotcha. Thanks.
Oh, you're welcome. No problem. How's this for a fixture? This is pretty cool. this is the kind of stuff I'd really like to be doing in CAM too. It's just hard to find free resources for stuff like this. Like I've never seen a tombstone built like that. I don't know where the hell you get that model from. Oh.
So you already did the outside of it. So now you want to do a contour. So what I would do is I would get out of that and see number 6. Because you're right, number 5 is the only one. And you're on step number 2, you from the outside you can on. So you just contour. And then turn that solid stock block off. And so what you're contouring is the outside of the front, right? So if you get the bottom of the stage, it should move all the way around the bottom. Yeah, it's okay. I mean, you could have done it with dynamic, but the problem is you're going to machine all this again. Yeah, you don't need to.
Hell is that crazy Cassidy? No, the master CAM file can be just submitted normally.
There's only one file.
So
Yeah. Yeah, the SolidWorks, I mean, you have all the files, so that's where you
okay, Matt. So I'm going to stop the recording and wrap up. I probably could have stopped it a while ago, but
Sounds good.
I'll see if I can find some way to trim it down and edit all the dead air out. Let me know if you have any questions. Otherwise, have a great week, all right?
You too, Sean. Take care.
Thanks. Thank you.
All right, take care.
Bye. Turn this off.